Can you see the screen?
Yes, sir. Yes.
Yes, sir.
Okay, so what we discussed last time. So keep your mic off. Shraddha Dongre, keep your mic off. Okay, so what we discussed last time. So if f is for function from a to b, then graph of f is gf, right? And what is this? Pairs such that y is equal to fx for x in domain. So ultimately what happens? So graph is a subset of what?
A cross B.
So Cartesian product of A and B, because if x is in A and f of x is in B, so it is value of function at x, so it is in B, so it is a pair of elements from A and B, so it is subset of A cross B. So now if f is a function from R to R, right, then what is the graph of f? Graph of f is x comma fx, x in R, and so it is subset of what? R cross R.
R.
So this is clear. So this is a subset of R cross R, and therefore last time I gave you. So thus, what is the conclusion? If f is a function from R to R, then graph of f is a subset of R cross R. Right. So for example, if I define function from R to R, fx is equal to x square, then what is the graph of this function? Can you tell me what is the graph of this function? X fx, right? X in R. But what is this? Those points. But what is fx?
X square.
X square.
X.
X in R. Right. Or I can write it as in alternative way, xy such that y is equal to fx, means x square, and where x is from R. And if you try to plot those points in R2, right? So clearly this is a subset of R2. R2 means R cross R. So if I try to plot such points, so what I will get this, right? And we generally say that this is y is equal to x square, but basically what is it? It is a set, right? It is a subset of R2, because we can draw it in R2 in plane, right? So for simplicity, we generally write that parabola y is equal to x square, but actually it is this set, pairs, right? So if you have function from R to R, then graph is a subset of R2. Now the question what I asked last time. So if we have, what is a reverse process? What is a what this example or previous discussion suggests? If you have function, then it gives us a subset of R cross R. If you have a function from R to R, then it gives us a subset of R cross R, which is a graph of that function. So what is a reverse process? What is the reverse process? If you have a subset of R2 is G, a graph. Do you understand the question? Do you understand the question? Can G be a graph of some function? Do you understand? Question is clear? What I want to ask? Clear or not? You tell me frankly. If you're not clear, I will explain it again.
Sir, could you please explain it again?
Yes. So see, if you have a function, then that function gives rise to a subset of R cross R. Right? That gives rise to a subset of A cross B. Right? If you have a function from A to B, if you have a function from A to B, then that gives rise to a subset of A cross B, which is a graph, right? Of function, which we call as a graph. Is it clear? This sentence is clear?
Yes, sir.
Yes, sir.
Now, what is my reverse process? Reverse process is, suppose we have a subset of A cross B, then can that subset be a graph of some function? Right? Alternatively, if f from A to B is a function, then graph of f is a subset of A cross B. What is the converse to this converse statement?
If G of f is a subset of A cross B, then f
If
is from A to B is a
so
function.
if G is a subset of A cross B, then does there exist a function f from A to B such that graph of f is G? Now question is clear? Question is clear?
Yes, sir.
Yes, sir.
So if you have a function that gives rise to a subset of A cross B, suppose we have and it is a graph of function, right? But if you have a subset of A cross B, is it a graph of some function? Right. So this question I asked last time. And what G I gave you? X square plus y square is equal to 1. I gave you this set. Is it a subset of R cross R?
Yes, sir.
Right. So
Yes,
this is a
sir.
subset of R cross
Yes, sir.
R. Now my question is, does there exist a function? f from R to R whose graph is this subset of R2. Whose graph is G. Now question is clear, right?
Yes.
Can you sketch that subset? Can you sketch that subset in R2?
Unit circle.
Circle, right? So first of all, try to sketch it, and then you can understand. So it is a circle of radius 1. So this is a circle. Now this is my set. This is a subset of R2, and this is my set G. Right? Circle every point on the circle. Right? Now is it a graph of some function? At the previous example, this is my subset G, but this is a graph of some function, right? Y is equal to x square. If I look at this is a graph of some function in previous example. But in this case, is it a graph of some function?
No, sir.
No, right?
Can't be.
Why?
Because
Sir,
there is
Can't,
two values.
because for every value of x, there is two values of y.
right. If you look at this x, then there are two corresponding values, right? So xy1 and xy2. So observe that. Observe that if I take some point here, x is equal to 1 by root 2 and y is equal to 1 by root 2 y1 and y2 is equal to minus 1 by root 2. Then we know that is a function. So x y1 and x y2 both are in G. Is it true?
Yes, sir.
That is
Yes, sir.
1 by root 2, 1 by root 2 and 1 by root 2 minus 1 by root 2 both are in G. And this is a relation actually, but this cannot be a function. Why? Because for 1 upon root 2 there are two images, right? So G cannot be a graph of any function from any subset of R2, right? So this cannot be a graph of any function defined on any subset of R2, no matter what subset you choose. This cannot be a graph, right? Cannot be a graph of any function on a subset of R. So this is clear. This is clear,
Yes, sir.
right? But I can have. I will give you another example. So let G1 is equal to xy such that y is positive and x square plus y square is equal to 1. Now can you sketch this set as clearly it is a subset of R2, no doubt. Can you sketch this set?
It's a unit circle.
But there is one more condition. What is it?
Semicircle.
It's a semicircle.
Semicircle. Half
Semicircle.
semicircle unit.
So y coordinate is non-negative. So this part only. here minus 1, 1. So right, this is G. Is it clear?
Yes, sir.
Because I am not
Yes, sir.
considering negative values of y. So that I have clearly mentioned in the set. So now this is only half. Is it a graph? Is G1 a graph?
Yes, sir.
Right. So it is a graph of some function. And what is that function? So fx is equal to square root of 1 minus x square. You check this. And I am restricting my domain minus 1 to 1 so that this is well defined, right? Because my domain is what? Minus 1 less equal x less equal 1, and therefore x square is less equal 1, and therefore 1 minus x square is greater equal 0, not negative. So square root is well defined. Am I right? Then okay, so do you agree with this?
Yes, sir.
Right, so clearly this is a function of a graph of some function. So one more example I will give you so that you can conclude something. So G2 is it a subset of R2?
Yes.
Is it a subset of R2? Right. Can you sketch this subset
Yes.
of R2? Which set is this?
It is
It is what?
para.
Parabola.
But this parabola is symmetric about x-axis. Right? It is symmetric about x-axis. Is it a graph?
Yes, sir.
No, sir.
No, sir.
Because
No, sir.
if you look at what? For example, 1, then 1, 1 and 1 minus 1 are in G2, right?
Yes.
That means 1 is related to 1 and 1 is related to minus 1 also. And for function, one element cannot have two distinct images. One element cannot have two distinct images. So if you recall the definition, for every element in domain, there must exist unique image. So G2 cannot be a graph of any function. Any function f any function on subset of R. You choose any subset, this cannot be a graph. You cannot get this set as a graph of any function on any subset of R, right? So now can you tell me how geometrically you can understand easily whether that set is a graph or not? You just compare these three examples. Observe this figure. Observe this figure. So in this figure, if you observe what happens, if you look at this point, this point
Vertical line
corresponds
test.
to right vertical line test. If you look at this case, this point corresponds to two distinct points. So that's why it fails to have be function. Right. So this is called as a vertical line test. Right. So vertical line test. So if you draw vertical line, if line intersect at two distinct points, then certainly it is not a graph because the corresponding points, so corresponding points has two distinct possible images. So that is not. So is, suppose I draw this curve, is it a graph of some function?
No,
No,
sir.
sir.
No, right? Because this particular x corresponds to many values, y1, y2, y3. That means xy1, xy2, and xy3. So same x corresponds to three distinct points, and that is not according to the definition of function. So this cannot be graph. Right, so this is a simple observation and everybody should know these kind of things, otherwise your knowledge is incomplete. This is not very difficult, you already have learned this such kind of things, but you should remember the fundamental properties of function. Right.
So, excuse me, sir.
Yes.
There's no difference between a graph and a function.
See, graph of a function. What word we are using? Graph of a function. If you have function, its graph is a curve, and which is a subset of a cross b or r cross r if it is real valued function. So, what is a graph? Graph is again general word. So, in what context you are talking? Graph of a function is a different thing, and in general, graph is a different thing.
So this recent example, we can say it's a graph, but not a function.
Which graph? No, what was my question? Is it a graph of a function? Question was, is it a graph of a function? Graph is a general word, right? So, graph is a very general word, and there is a separate branch of mathematics called as a graph theory. Right, and you search on Google what is a graph theory. It is a huge branch and it has lots of applications in everywhere, computer science, physics, space science, everywhere. And in that case, graph is again different thing, right?
Okay, sir.
But here we are talking about graph of a function because in our back of our mind there is a function, definition of function, concept of function. In that context we are talking about the graph, right?
Yes.
Right. So greatest integer function. So greatest integer function. So if you define fx by this, right? So we denote it by this symbol, and you already know this greatest integer function. So what is it? The greatest integer less equal x, right? Greatest integer less equal x. So minus 1, so on. So if these are integers n plus 1 and if my x is here, right, then for this particular x, what is the greatest integer? N,
N.
right? So look at all the possible integers less than or equal to x, and among which is the greatest, right? That is a value. So for example, what is f of 1.5?
1.
1. So look
1.
at the smaller integers than x and which is the greatest. So, but what is f of minus 1.5?
-2.
Minus
Minus 1.
minus, so minus 1.5. Look at all the integers less than minus 1.5, which is the greatest, minus 2. Right, so the question is, if I define from R,
Excuse me, sir.
yes,
Sir, since it is said as greatest integer, but minus 2 is less than minus 1, right? So it must be minus 1. Because
okay.
when we draw the graph, it comes out to be minus 1.
Yes, greatest integer less than or equal to x, right? So all integers less than or equal to x, look at all the integers less than or equal to x and which is the greatest. So if you look at minus 1.5, what are all the integers less than or equal to minus 1.5? Minus 2, minus 3, all, which is the greatest? Minus 2.
Okay, sir.
Right, now sketch graph of f. Now try to sketch the graph of this function. Right, so if x is in between 0 and 1, so if x is lies in between 0 and 1, then what is the value of function?
0.
0.
0. 1 less equal x less than 2. So
1.
1, right? So but at one value is not 0, at one value is 1.
1.
Right, so here I fill because value at, and at 2 value is not 1, at 2 value is 2. Right, so if 2 less than or equal to x less than 3, then it is 2. So at 2 value is 2, and after that up to 2, but at 3 value is not 2, it is 3. So here I am hollow circle, means value is not at so 2 is not value at 3. So in that way you can have a graph, but minus 1 to 0 is minus 1, right? And at 0 value is 0, right? Here hollow circle. So minus 2 to this is minus 2. In this way you can look at the graph of this function. Fine. Okay, so this is clear. Now you try to sketch the graph of another function, which is so f of x is equal to x plus, right, g from R to R, gx is equal to not 0, right? So you just try to sketch the graph of these functions. Okay, let A and B are two subsets of okay, not A and B, just consider simple case. Let f is function from R to R and g is also function from R to R. So we have two functions B. Right. Then, so suppose these two functions are given, known, right? Whatever this may be, but suppose these are given functions. Now, what I want, okay, suppose this is my function f, graph of f. Is it a graph of function?
Yes, sir.
Right. Uh, Now I have another function. G. Right. Now I want to define new function. So define. So suppose f and g are known. So define phi from R to R by phi x is equal to maximum of. So is this function well defined? Well defined means what? Does it satisfy definition of function? How I am defining this function? What I am looking at. So I want to define everywhere function, but at this particular x, what is a phi x? At this particular x, what is a phi x?
GX.
Gx, right? Because whichever is a maximum, fx and gx. So this is what this point is x comma fx, and this point is x comma gx. So which is maximum, fx or gx? So gx is maximum. So at this point, I am defining phi x to be gx, right? But at this particular x1, what is a phi x?
F of X.
FX.
Right. So here x1 gx1. So whichever is maximum, that I will say that the value that I will call as the value of phi at x. So when we talk about function, so and we know the domain, when we say that function is well defined, that function is defined at every point in the domain and it gives unique image. So now is this phi well defined first of all? Do you understand? Is it well defined? Is it defined at every real number?
Yes.
Yes.
Because the G of X are defined at every real number.
So phi is well defined everywhere because f and g are well defined, and therefore whatever value of f and g at any x, I will choose maximum, again well defined, because if you are two numbers, then maximum of two numbers always exist. In general, maximum of infinitely many elements does not exist, right? For example, if you look at interval 0 1, then maximum does not exist because there are infinitely many elements in the interval, right? But if you have finitely many elements, then easily we can choose which is a maximum, and therefore here only two numbers. So you just choose any real number x, and what is a phi x? Look at fx gx, and which is a maximum, that is your phi x, right? So do you understand this is a well defined function, right? Am I right? Now what is a graph of this function? Can you see this function? This is origin, right? 0 0. Now I will just replicate this above uh, things here, and now I want to draw the graph of phi x, right? So can you tell me what is the graph of phi x? Okay, at this x, what is a phi x? At this x, do you see the,
GX.
it is gx, right? And therefore here my phi x will be same as gx because gx is maximum. Okay, after that, up to this point, right? After that, what is phi x?
FX.
Fx, because fx is maximum till this point. After this, which is maximum? Gx.
Hmm.
Correct? Now, can you see the graph of phi x now? Is it easy to see graph of phi x? I will just replicate these points, and then what is the graph of this phi x? Up to this point it is like gx, after that it is like fx, and after that it is like gx. Do you see the graph? Right, this is a graph of phi x. Okay, the idea is clear. Idea is clear.
Yes,
Yes.
sir.
Right, so what is the maximum? And clearly it is a well defined. Similarly, so define psi x, psi from R to R by psi x is equal to minimum fx and gx. So minimum. Now, similarly, now you can understand what is a maximum and what is a minimum. Is it clear?
Yes, sir.
So let me call this as suppose some point A and this as point B, and okay, so this is A and this is B. I am just looking at phi x now, and therefore can you give me precise definition of phi in this case, in this particular situation? Okay, let me use different colors so that for this particular graph in particular situation. So if x is less than or equal to A, what is it?
GX.
Gx, right? And if A less than x less than or equal to B, what is it? Same as fx.
fx.
And if x is greater than B, it is same as gx. So this is a precise way to say that what is phi x in this particular graph, not in general. In general, it is maximum of fx and gx. But if you look at this particular graphs, then this is a definition of phi x. Similarly, you write down definition of psi x in this particular situation, right? Can you write this now? Right? Okay, so let f from R to R, okay, R to R, or I'll make it simple. F from not R to R, so I will consider some smaller interval, minus 3 pi to 3 pi. Fx is equal to sin x, g from to R, gx is equal to cos x, right? So functions are clear. Then what is a phi x? Phi from minus 3 pi to, okay, so let me write it precisely.
Sir, can you please just scroll up? Yes, sir.
Yes. Okay, so is it complete?
Yes, sir. Yes.
Okay, now define phi from minus 3 pi, phi x is equal to maximum of fx gx, and psi x is equal to minimum, and then you sketch the graphs. Psi from psi x is equal to minimum. So question is sketch, uh, then then obtain precise formula for phi and psi. Second, sketch graphs of phi and psi. So question is clear?
Yes, sir.
Right. So precise formula. What do I mean to say precise formula? So like this. How I have written phi in this way in terms of f and g. So what precisely phi and psi are, and then sketch the graphs. So this is a good exercise. You should work it out. Right. So let R to R fx is equal to x square minus 1 and gx is equal to 1 minus x square. Same thing I am repeating. Maximum of phi psi functions from R to R. Maximum of fx gx psi x is equal to minimum of fx gx. Right. So repeat the above things. What is phi and psi explicitly? Explicitly means what is the precise definition? And sketch phi and psi. Fine. Okay, so any doubts so far? Any doubts? Everything is clear?
Yes, sir.
Right, so very good. Now let us go to the more about, so now we'll try to understand more about the functions. Right, so these are just basic various types of functions. So now we'll try to discuss about bijective functions, and bijective functions are very important. They have many significance in analysis in mathematics. So are one function or surjective injective function, one function or injective function. So injective means what? The function maps elements inside, like injection. So a function f from a to b said to be 1 or injective if distinct elements in A have distinct images. Have distinct images in B. That is said to be one. So distinct elements in domain must have distinct images in codomain. Means what? 1 if x1 and if for let me write more precise. So if for x1 x2 in domain x1 and x2 are distinct, mean not equal, then their images, right, are also unequal. If elements in domain are unequal, then their images are also unequal. That is what the simple way to say that function is 1. So for example, if I have a set A and set B and f is a function from A to B, so this is f. So A, B, C and D. Here 1, 2, 3, 4. So okay, is this a function? Is this a
Yes,
function?
sir.
Yes.
Right.
Yes, sir.
Yes, sir.
A is mapped to 1, B is mapped to 4, C is mapped to 2, D is mapped to 3, right? So this is a function because every element of domain is mapped to some element and it is unique. So f is 1 function. Is it true?
Yes, sir.
Yes, sir.
Distinct elements are mapped to distinct points in codomain. Now, so if I look at A, B and f is a function, so A, B, C, D, 1, 2, 3, 4. Okay, is it a function?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
f is a function, but is it a 1?
No, sir.
No,
It's
No,
sir.
sir.
many one.
No.
Right.
No, sir.
No.
So A and B are members of domain. They are distinct members, and f of A is same as f of B. Right. So therefore, this f is not injective or not 1 because two distinct elements are going to same element. Right. So 1 correspondence, 1 map. So if I define so A, B, C, D, and I have map from this to this 1, 2, 3, 4, 5, whatever. So I map everything to 1. Right? Now, is it a function?
Yes, sir.
Yes,
Yes.
sir.
Right. So what is the simply f of x is equal to 1 for all x. Everything is mapped to 1. So but not 1 is a function but not 1 function. Right. So this is a function but not 1. Now let us go to some non-trivial case. So if I define f from R to R, fx is equal to x is f11. You sketch the graph. What is f of x is equal to x graph?
Straight
Line.
passing through origin.
Right? So the points having x and y coordinates equal. So on this line y is equal to x. So this is a function, no doubt. But is it a 1-1 function?
Yes, sir.
This is a 1-1 function. So check this. So let I choose x1 and x2 in domain, right? If x1 is not equal to x2, right? Suppose x1 and x2 are unequal, but x1 is same as f of x1, right? X1 is same as f of x1, and what is x2 is same as f of x2, but x1 is not equal to x2, therefore their images are also unequal, right? Right? Therefore, f is 1-1 because images are unequal. If elements are unequal, their images are unequal. That means distinct elements goes to distinct. So if I define fx is equal to x square, then what is the graph?
Parabola.
Right, parabola. Now is it 1-1?
No, sir. No.
No. Why?
Because one has two elements.
So if I take x1 is equal to 1, x2 is equal to -1, then x1 is not same as x2, but what is f of x1 is f of 1, which is 1, and f of x2, which is f of -1, is again 1, so that f of x1 is equal to f of x2. So two elements are unequal, but their images are. Therefore, there exist x1, x2 such that x1 and x2 are unequal, but f of x1 is equal to f of x2. So this is what is happening here, right? Therefore, f is not 1-1. Basically, what is happening? Ki -1 is here, right? And 1 is here. And what is the value of 1 is 1, value of -1 is 1. Same thing at -2, correct? Same thing is happening at 2 and -2, correct?
Yes, sir.
Yes, sir.
Right. So therefore, there are many elements which are unequal, but the values are same. So that this is not a 1-1 function. But from this graph, what is happening? So this point 1 and this point. So if you draw horizontal line, this horizontal line intersect graph at two distinct points. That means these two distinct points are at same level and they corresponds to two distinct elements in the domain. Correct?
Yes, sir.
Right. So, but in this case, y is equal to x. If you draw horizontal line intersect only at one point, and therefore the corresponding point is only one point to this level, this height, because y coordinate is a height, and if you get same height for two distinct points, that means these two distinct points have same value, same height, right? But that is not happening in case of y is equal to x. Is it clear? Do you understand what I want to say?
Yes, sir.
So if we consider a graph, suppose I look at a graph of some graph So is it a graph of a function? Is it a graph of some function? Yes.
Yes, sir.
Yes. Yes, sir.
Yeah. So yes, no doubt, because by vertical line test, every point corresponds to unique point. Now, is it a graph of one function?
No, sir.
No.
No, right? Because if you draw horizontal line, then what happens? What happens? I will get 2 points x1 and x2. And what is f of x1? This height is f of x1, which is same as f of x2. Right? Because these 2 points are at same level. These 2 points are at same level. So x1 is not equal to x2, but fx1 is equal to fx2, and there are many such pairs x1 x2, and therefore this is not the graph of one function, right? So this is called as a horizontal line test. Right, so what is horizontal line test? So draw a horizontal line to the and if that line intersect two distinct points, if at all such line exists, then function is not 1 right? So this is a simple criteria, and from the graph itself you can easily recognize whether it is 1 or not. So if I define f from R to R, fx is equal to sine x, right? So is f11. Is f11 sine x?
No, sir.
No, right?
No, sir.
So sine is not 1, but you can look at function from minus pi by 2 to pi by 2. Same function. Now is f11.
Yes, sir.
Yes, sir.
Yes, sir.
You think about this. So this is 1 is f11. So you think about exponential function, right? Fx is equal to log x positive is f11. So fx is equal to absolute value of x on R is f. So you think about all these problems. Next time we'll discuss more about one functions and bijective functions. Right? So any doubt?
No, sir.
So whatever we discussed today, everything is clear now?
Yes.
Okay, so you try to find answers of the questions that I gave for exercise. That will be better so that next time we can understand the more properties, right?